We're going to do problems 6, 7, 8, and then 9 on the next page. That's your assignment, 6, 7, 8, 9. If you seem to be getting the hang of it, feel free to stop the video and work on your own, and you can check your answers tomorrow or come back to the video and check your answers. If you notice in these problems, for each of them, you're going to have to start by writing a balanced chemical equation. I'm not going to spend a ton of time on the videos on this part because it would take up a lot of time, so I'll kind of fly through that a little bit and focus on the stoichiometry. If you take a look at number 6 says 22.8 grams of sodium hydroxide is reacted with hydrochloric acid. How many grams of water is formed? So the problem tells us that we have sodium hydroxide reacted with hydrochloric acid, and that would be a double replacement reaction. So the sodium and the chlorine, 1 plus and 1 minus, NaCl. The hydroxide and the hydrogen ion are going to make HOH, which is H2O. And it looks like that equation is already balanced. So I'm going to label it like I usually do. The problem says 22.8 grams of sodium hydroxide is what I'm given. How many grams of water is formed? So that's what I'm looking for. This is going to be a 3-step gram to gram stoichiometry problem. So I'm going to start with 22.8 grams of sodium hydroxide. We're going to do 3 steps. The first step is going to be grams of sodium hydroxide to moles of sodium hydroxide. I'm going to look up the molar mass for sodium hydroxide on the periodic table. And I get 40.0. Comes out to about 39.9969. So I rounded that to 40.0. Grams of sodium hydroxide cancels out. I'm going to put moles of sodium hydroxide on the bottom. This is my mole ratio step. So this is where I go from moles of sodium hydroxide to moles of water. The ratio in this case, it's a 1-to-1 ratio. You still have to include that step even when it's a 1-to-1 ratio. Then I'm going to convert from moles of water to grams of water. If you look up the molar mass of water on the periodic table, we have 16, 1, and 1. Comes out to 18.0148. That's one I just happen to know off the top of my head, but if you add that up, use your periodic table. 1 oxygen, 2 hydrogens. And I'm going to do my math. 22.8 divided by 40.0 times 18.0148. I get 10.3 grams of water as my answer. So when I start with 22.8 grams of sodium hydroxide, I do gram to mole conversion, mole ratio, mole to gram conversion. This number and this number both came from the periodic table. This was the mole ratio. I looked at the coefficients in the problem, and when I did my math, I get 10.3 grams of water. If you take a look at the next problem, number 7. So there were 4 practice problems we did, all pretty much the same gram to gram stoichiometry problems. If you have questions, feel free to watch this again. I know I went kind of fast through some of these. That's the nice thing about a video. You can stop it, rewind it, pause it as you need to. Watch it again or bring questions to class and we'll definitely clear things up for you. Number 7 says 32.5 grams of iron 3 chloride reacts with silver nitrate. How many grams of silver chloride are formed? So again, we're going to need to start with a balanced chemical equation. Iron 3 chloride, so that's going to be FeCl3 if you check the charges. Iron is a 3 plus, chloride is a 1 minus, so that needs a crisscross. Plus silver nitrate. I know that silver is a 1 plus and nitrate is a 1 minus, so that's just going to be AgNO3. Double replacement reaction, so iron nitrate, that's going to need a crisscross, and then AgCl. Silver's a 1 plus, chlorine's a 1 minus. I'm going to need to balance this one, So I'm going to put a 3 here. If this is going a little bit too fast for you, feel free to pause the video. So let's see, 1 iron, 3 chlorines, 3 silvers, 3 nitrates. That one looks balanced. All right, now it says 32.5 grams. I always like to label right under the equation or above it, just so I know where I'm going. And it says how many grams of silver chloride are formed. So we're starting with 32.5 grams of iron 3 chloride, and we want to know how many grams of silver chloride. So again, 3 steps. We're going to start with 32.5 grams of FeCl3. Grams, FeCl3. This unit always comes down here to 1 mole. Molar mass of iron 3 chloride. I get 162.2. Okay, 162.2. That unit cancels. We do moles of iron 3 chloride to moles of AgCl. So moles of this to moles of this. This is my mole ratio step. 1 in front of the iron 3 chloride, a 3 in front of the silver chloride. Bring this unit down, 1 mole AgCl, grams of AgCl. I look that up on the periodic table. 107.87 plus 35.453. I get 143.3. Okay, and this unit cancels out. I'm left with grams of AgCl, and I need to do my math. 32.5 divided by 162.2 times 3 times 143.3 gives me 86.1 grams of silver chloride. So again, molar mass step, mole ratio step, molar mass step. Problem number 8. Again, we need to start with a balanced equation. 34.5 grams of lithium reacts with chromium 3 chloride. So that would be CrCl3. If I do the crisscross there, the 3 Roman numeral goes with the chromium. So that would be Cr with a 3 plus, chlorine's a 1 minus. So when we crisscross that, we get CrCl3. And then let's see, the chromium is going to get kicked out on its own, plus LiCl. Lithium's a 1 plus, chlorine's a 1 minus. And we need to balance that one. So it looks like a 3 and a 3. And the problem says 34.5 grams of lithium reacts with chromium 3 chloride. How many grams of lithium chloride is formed? So we're going to start our problem. Three steps. We're going to do grams of lithium to 1 mole of lithium. Molar mass of lithium is 6.941. Grams of lithium cancels out. We're going to do moles of lithium on the bottom. This is our molar mass step. To moles of LiCl, lithium chloride. So moles of lithium to moles of lithium chloride. Oh, the ratio there is 3 to 3. You can reduce that to 1 to 1 if you like to. I usually just keep it 3 to 3. Moles of lithium cancels out. Then we do moles of lithium chloride to grams of lithium chloride. Okay. Molar mass of lithium chloride 6.941 plus 35.453 gives me 42.39. Do the math here. 34.5 divided by 6.941 times 3 divided by 3 times 42.39, and I get 211 grams of lithium chloride. So hopefully you'll see the repetition in these problems. This was our molar mass step. This unit always comes down here. Grams of lithium per 1 mole of lithium. It's always the same thing on the top and the bottom of this one and this one, but the substance is different here. That mole ratio step is how we get from substance A to substance B when we're using our roadmap. It's that mole ratio step in the middle. Let's do one more practice problem together, number 9. (43.5 grams of copper 2 sulfate is reacted with barium nitrate. So let's see, copper 2 sulfate, so that'd be CuSO4 plus barium is a 2 plus, nitrate is a 1 minus. Again, I said I wasn't going to spend a ton of time on the equations in this video just to keep it moving. Double replacement reaction, so we're going to do CuNO3 2 plus BaSO4. Balance, let's see, copper, sulfate, barium, nitrate looks good. Let me double check those charges, 2 plus 2 minus, 2 plus 1 minus. Okay, so how many grams of precipitate are formed? Ooh, this is a tricky question. So it says 43.5 grams of copper 2 sulfate. Okay, so 43.5 grams of copper 2 sulfate is reacted with barium nitrate. How many grams of precipitate is formed? So what you have to do is look at your solubility chart to figure out which one of these is your precipitate. Now I know on my solubility chart that every nitrate compound is soluble, so I know that this is going to be an aqueous solution. That means my barium sulfate would have to be my precipitate in this case. So if you grab your solubility chart, I happen to have one right here beside me. That was just lucky. Barium sulfate is insoluble, so that would be your precipitate. So we're looking for grams of barium sulfate. So again, 3-step stoichiometry problem. Okay, we're going to do grams of CuSO4 on the bottom. 1 mole of CuSO4 on the top. Notice whenever we have grams on the bottom, it's always 1 mole on the top. We use the coefficients in this middle step right here. So molar mass of copper sulfate should be around 159 something. So let's see, 63.546 plus, oh, I was wrong. 63.546, I made a mistake. Okay, 159.6. Okay, that unit cancels. So we bring moles, CuSO4 down here, to moles of barium sulfate. That just happens to be a 1-to-1 ratio. Okay. And then moles, BaSO4 to grams. So I'm going to add up that molar mass. Your periodic table is getting a lot of use today. So 233.4 grams of barium sulfate. Okay. Okay, and the correct answer, 63.6 grams of barium sulfate.